Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Narrow Roads by Fuchsia. And here are the rules. We have normal Sudoku rules apply, which means place a digit from 1 through 9 in every cell such that there are no repeats in any row, any column, or any designated 9-cell region. We have also digits along a gray line sum to the same value as the circles on either end, combined. Numbers on the... Okay, so for example, if this... Well, we only have one type of line, interestingly enough. So this, for example, would be... If this is 3 and 4, this would have to be 7. So it's kind of like the opposite of an arrow because the sum are essentially the two digit. The way that this is constructed, the sum are the two digits in the circles, and the digit on the line is a sum of those two digits. So it's sort of a reverse arrow sort of thing. We also have numbers on the outside give the sum of the digits on the indicated diagonals, which is a little killer clue. So the sum of these 7 digits must add up to 26. The sum of these 7 digits must add up to 38. And the sum of these 7 digits add up to 13. While the sum of these 9 digits here add up to, not including this one, 49. So that's how little killers work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the one that seems the most restrictive to me is the 13 along this diagonal. The 45 might be as well, but the 13 seems particularly interesting, right? This is the sum of these two digits. This is the sum of these two digits. This is the sum of these two digits. So it's essentially, so this is a sum of these two. This is the sum of these two. This is the sum of these two. What's the maximum in these cells? So this is the sum of these two digits. So you have these 4 digits. The minimum obviously is 1, 1, 1, 1. So that would mean the maximum for these digits are 2, 2, and 2. Sorry, the minimum for those digits are 2, 2, and 2. And they all could be that way. So how many degrees of freedom do we have? 1 times 4 is 4, plus 2 times 3. Is that right? 1 times 4 plus 2 times 3. Yes. So that's 6 plus 4. It's 10. We have 3 degrees of freedom along this diagonal. And the way I use degrees of freedom is basically what can a digit increase to, right? If you have 3 degrees of freedom, and what can the lowest digit increase to? If we have the lowest digit here being a 1, we have 3 degrees of freedom, it could go up 4, or go up to 4, right? But the problem with doing that, so we don't have 3 degrees of freedom in the circles, because any change in the circle is reflected in a change in the digit that must add up with the circles, right? So again, minimums here are 1, 1, 1, and 1, right? That means this is minimum 2, 2, and 2. Though this adds up to 10. If this were to increase from 1 to 4, using all 3 degrees of freedom, the problem is this would have to increase from 2 to 5, which also would use 3 degrees of freedom. So we would actually be using 6 degrees of freedom, jumping from 10 to 16, which is not allowed because this adds up to 13. I think this can only increase, in the circles, you can only increase by 1, right? Because if you increase by 1, actually, how does that work? To add up to 13, I don't think it can even increase by 1. If it increases by 1 here, that means this has to be 3. So it also has to increase by 1 in every other cell for the outside circles. For the inside circles, that actually works. So the outside circles must be 1. So they have to be 1 because, again, so if, let's take a look. What happens if we increase this to 2? If this increases to 2, this has to be at least 3, right? But then this adds up. We've already used 2 degrees of freedom. So this should add up to 12, right? 6, 2, 1, and 2, 1 add up to 6. That's 12. So if we tried increasing one of these digits, the problem is that would increase another digit too. And therefore, you would never work that way. So, and the only places, so the thing is, anything that increases on the inside, sorry, if you have any circle increasing, you will increase a digit on the inside too. So therefore, in between the circles, shall we say. So the thing is, the digits on the in between the circles can never increase on their own. They have to come from an increase in a circle. So therefore, you have to have an increase in the circle that uses exactly 3 degrees of freedom, which means it has to be exactly this one or this one. So these are 1 to 2. This has to be a 1. So this is a 1 and this is a 1. This is 2 or 3. This is 2 or 3. This is 2 or 3. And this is 2 or 3. Or sorry, this can't be 2 or 3. This is 1 or 2. So the inside circles can increase by 1, and that would increase both of the sums on either side, which would give you the 3 degrees of freedom that you would have. So this is 1 or 2, this is 2 or 3, this is 2 or 3, 1 or 2, 2 or 3. What about the outside? Can we do something similar? You could have 9, 9, and 9. So 9, 9, and 9 add up to 27. If you had 4 and 5, this would have to be 4, and then this would be 5, if that were the case. So 9, 9, and 9. Either way that this happens, you have to have 2 of each digit here. Right? This would have to be the same as that. This would have to be the same as that, right? Because these would add up to 9, and these would add up to 9. So these two would have to be the same digit. If this adds up to 9, these two would have to be the same digit. So this would be at most, it has to be 9, 9, and 9. Because these add up to 9 at most. These add up to 9 at most. And then we have 5 9s essentially across this diagonal. That's the maximum amount possible, and that is equal to the value of this. So this has to be 9, 9, and 9 here. And these have to be 1 through 8. Obviously, this can't be 1. Actually, neither of these could be 1. So since neither of these can be 1, it can't be 1 and 8 adding up together. It could be 2 and 7, or 3 and 6, or 4 and 5. Right, because these two digits add up to 9. These two digits add up to 9. And these two digits add up to 9. But both of these see this 1. So this has to be 3 through 8. And this is 3 through 8 here. What can these be? Well, none of these sums can add up to 9. So what is the maximum these sums can add up to? 8, right? And then you have a similar problem, right? You have 8, 8, 8, 24. These two must add up to 8, and these two must add up to 8. So we have essentially 2 degrees of freedom. So we have 2 degrees of freedom here, and it has to be a change from the outside. If it changes from the inside, so it goes down, so say this was a 7 and this was 1, and the 7 went down to a 5, that would affect both of these sums. Would it? No, that's not the case. Right? Because we can compensate on this end. Okay, that's not guaranteed. So we have 2 degrees of freedom. Well, essentially, it's 1 degree of freedom everywhere. Right? Because if this goes down by... That's not true. No, that's not true. We just have to have the 8s in the middle. Right? Hold up. Actually, does this work then? Yes, because 8s work differently than 1s and 2s, right? So 8s and 9s work differently than 1s and 2s. Here, a strict increase anywhere increases any 2 specific spots if it's on the if it's on the outside, and 3 specific spots if it's on the inside. So that's the reason why that works. But you can always compensate for large digits on the outside. Um, okay. Right, because the restriction is actually not started by the digits in the circles. They're actually started by digits in um, in the lines here to add up to 38. So this is at most 8, at most 8, at most 8. We have 2 degrees of freedom along there because these add up to at most 8 here. So it would be 8 plus 8 plus 8 plus 8 plus 8 at most. That's 40. We have 2 degrees of freedom. The circles could decrease by 2, and that would be fine, I guess. Okay, this is... You only have 2 degrees of freedom at most. This would be at 7 at most. Can you ever have a 4? I don't think so. If you have 4 and 2 here, that would add up to 6, and this would already be 12. Even if this is 8, 8, and 8, that's 24 plus 12, which is 36. So no, this can never be 4. Again, 2 degrees of freedom. Can this be higher than 5? No. If this is 4 and 5, that's a minimum 9, right? So this has to be 1, 2, or 3. It cannot be 1. Aha, this is already... So this can't be 7 here. If this were 7, this would be minimum 2. And therefore, this would not add up to less than 9. And we already have a 9 in all of these spots. So this can't be 7. This is 5 or 6. That's interesting. Can this be 5? I think so, right? Can this be 1 and 5? I don't... maybe, yeah. 1, 5 adds up to 6, but then you could have 7 here, 8 here. Wait, 1, 5. If you have 1, 5 here, that makes this 6. That could be 1, 7, and this could be 3, 5. So you have 3, 5, which adds up to 8. 8, 6, 1, 8, 1, 7, and 8. And that does add up to 38. So that actually does kind of work. Can you have a 5 here? Probably, right? 5 and 2, 7. This adds up to 26. Okay, so what do these diagonals specifically add up to? Maybe this will... Oh, no, that's not helpful. That's pretty spaced out. Okay, this is 5 or 6. Since this is 5 or 6, it can only be with 3 or 4 here to add up to 9. So this is 3 or 4. This is 3 or 4. This is 5 or 6. Yep. It has to be added up to 3 or 4. This is the same as that. This is 3 or 4. Ah. Well, no. Okay, so this can never add up to 6 here. Because this is at minimum 2 and 5. Again, you can't have 4 here. 2 and 4 even adds up with 6. So 2, 4, and 6 adds up to 12. Or actually, 6. Well, actually, no. Maybe 4 could be here. Yeah, it could be 4 and 4 on the outside. You just can't have a 4 here. The 4 could be here. Right? 4, 2, and 6 works as long as this is 6, so that's 8. So it's 8 plus 8. And this is 4 and 4, we'll work with 8 here. As long as this is 6, right? You have 6 here. Then these two would add up to 8. You'd have 8 here. You'd have these two add up to 8. This would be 8 here. So that's 32 because it's 8 times 4 plus 6. So that does work. So 4 can be here. Interesting. So then this could be 5. This is 3, 4, 5. This is 4, 5, 6. Therefore, this cannot be 6, 7, or 8. This can't be 6, 7, or 8. Actually, it can't be. It has to be 3, 4, 5, 6. Apologies. And this is 5, 6, 7 here. Okay. So this is 3, 4, or 5. Interesting. Right, so that was, can it ever be 3? No, because then this would have to be 5 and we lose 3 degrees of freedom here, which is not allowed. So that's not possible. But it could be 4, because it could be 2 and 4 here. These add up to 8. So you have 8 here, 8 here. These add up to 8, so that's 8 here. Can this be 6? No, because it would require that to be 2 and 4. You would already have a 4 and 2 here at most. So that would be 6 here. This would be 6, and that would be 6, and we'd already lose 2 degrees of freedom. Okay. So this is the same digit as either that one or that one. We're not actually, doesn't this have to be 3? Yeah, one of these increases its degree of freedom, which would increase the degrees of freedom on both of these or both of these. Either way, this is increased both times, so this has to be a 3. That's interesting. Okay. So both of these, one of these is 1, one of these is 2. So that neither of these can be 1 or 2. This has to be 3 through 9, but that doesn't really tell us much. This digit is exactly the same as this digit, and this digit is exactly the same as this digit here. That's interesting. So where can this orange digit be here? It could be any of these. Well, it can't be here because this is 6, 7, or 8 specifically. It could be either of these 3. Interesting. What's the minimum here? That's kind of curious. I'm curious about that. Um, I don't think it reaches 20. I don't think it's anywhere close to 26, unfortunately. Nine cannot be here or here. Nine can't be either of these. So in this box, nine must be one of those two. Nine has to be one of those two. Nine cannot be here or here, so it's one of those four, but that's pretty broad. So this cannot be nine. This can't be nine, and this can't be nine. So this is, again, 40 at most, but that doesn't tell us very much. What is it at least? This could be 2, 4, 2. This adds up to 4 through 8 here. This is also, it could be 4 through 7 here, because this is 3, 4, 5. This is 4 through 8, because this is at least a 3. So this is 1, 2, 3, 4, 5. 5, because 5 and 3 adds up to the maximum of 8. This could be 2 through 7 here. Oh, one of these two digits is a 2, right? So either this is 2, which adds up to 3, or this is 1, which adds up to 2. Same here. One of these digits is a 2. Okay, what does... Okay, so can this ever... If this is 5, this is 3. That's 8, obviously. This is 3 and 6, which makes this a 3. And this is 6, so this would be 7. This would be 4. So far, it seems fine. This is 4 and 5, adding up with the 1 and 2. This 6 means this can't be 6, so this is 7, or 8 can't be 8. This is 7. This must be 1. This is already 16. But that might be okay. This can't be 7. This is 1. We've already lost 2 degrees of freedom here, right? This has to be 2. This is 8. So this is 10 plus 14. This is actually, so this is 16 plus 8, 24. This must add up to 14. It can't add up to 14. So we've lost... if this is 8, this is 7. If this is 7, this is 6. If this is 6, this is 5. So we've shown that the 5 cannot be here. But that doesn't help us too much. Can this ever be 3 and 6 is kind of a good question, actually. If this is 3, this is 6. This is 6. This has to be 2. This is 8. We're not guaranteed here. So I guess this could be 8. And this is 2. So this is already 8 plus 8 plus 8. That's 24 plus 2 is 26. That means this adds up to 12, so it must be 5 and 7. That does seem to work okay. So can this ever be 1? That was actually very interesting, that we couldn't actually get that 1 to work very well, right? So we tried that with 1 and 6, right? So that forces this to be 7. This is 3. This has to be guaranteed 2, 6, 8, and 6, right? 7 and 1. So this adds up to 16 here. This is 8, 24. So this must be adding up to 14. But that doesn't work. Right? Because you have either 8, 7 here or 7, 6, which is 13, or 15, but not 14. So if this is 1, this cannot be 6. This would have to be 5. Can this work? This is 5, this is 4. This is 1, so this must be 2, which makes this 2. And this must be 3, but then this would have to be 6. So we have a contradiction because we have 2 6s in box 5. So this can never be 1 here. This has to be 2. So this is 2, this is 3, which forces this to be 1 and 2. And now this adds up to 13, right? So, yeah. 1 plus 2 is 3, plus 3 plus 1 plus 2, that's 10, plus 3 and 1 is, wait. 1, 3, and 2, plus 3 is 9, plus 1 is 10, plus 2 and 1 is 13. So it has to be this way. So this is 1, this is 2, this is 1. This added together with that must be 4, 5, or 6. 2's here. It adds up with 5 and 6 to add up to 7 or 8 here. So this is 2, this is 3. So 3 has to be one of these digits. These digits have to be exactly the same because they're the sum of these two. These different digits have to differ by 1. That's interesting. This is 1 plus another digit. So this cannot be a 2 here because 2 can't be here. 1 and 3 add up to 4. 1 and 4 add up to 5, etc., etc. So that's fine. 2 with 4, 5, 6 with 6, 7, 8 here. Okay, that's interesting. If this is 6, this is 3, obviously. This is 6, and that's 3. This would then be 8. This would have to also be 8. This 6 would force this to be 5, 7, and that does work. Right, and this would be 2. This would add up to 16. You'd have 8. So that's 24 plus 2, 26. 5 and 7 add up to 12. 12 plus 26 is 38. So that would work. What happens if this is 5? If this is 5, this is 4, this is 5, this is 4. So this becomes 7. This would force this to be 6 and 8. This already adds up to 16. 16 plus 12 is 28. So this would have to add up to 10. 2 and 5 does not add up to 8. 3 and 7 does not add up to 5. Sorry, 3 and 5 do not add up to 7. So this would break, right? Because we have, this is 16 plus another 12. That's 16 plus 12 is 28. And then 38 minus 28 is 10. And you can't have 2, 8 here because 5 and 2 do not add up to 8. You can't have 3, 5 here because 3, 5 and do not add up to 7. So that would break there. So this cannot be 5 here. So this can't be 4, this can't be 5, and this can't be 4. So this can't be 4 or 6. This is 4 or 6. This has to be 6 or 8. And this is 5 or 7 here. What about 4? Does 4 work here? If this is 4, this is 5, this is 4, and that's 5. Ah, but then this would be 6 and that would be 6, and we have a contradiction. So that does not work. So we know then this has to be 6 and 3, 6 and 3. That forces this to be minimum. This 6 means this can't be 6. This is 5 and 7. This 6 and 2 adds up to 8. This 6 and 2 adds up to 8. And that does add up to 38 along this diagonal. This is 1 and 3 adding up to 4. Same here. This is 1 and 6 adding up to 7. Okay. This can't be 1 because of the 1 here. This can't be 4 then. This can't be 8. So, yeah, 2, 3, and 4 does work. To add up with 5, 6, and 7 here. This can't be 7, so this can't be 4. So it's 2 and 3 here. 3 cannot be either of these. These add up to 8. What's the maximum if this is 4 and 3? Okay, this can't be 7. Since this can't be 7, these two can't add up to 7, so it cannot be 6 here. This can't be 3 because of the 3 in the column, so this can't be 4. This is at minimum 4 and 5. This can't be 5, and this can't be 5. Since this can't be 5, this can't be 6. This can't be 8 here, so this must be 5, which forces this to be 4. This can't be 4 or 6. It can't be 3. This is 7, 8, or 9. So this already adds up to, this is 10, 17. So these two must add up to 9, right? 26 minus 17 is 9. So again, 10 plus 4 and 3 is 17. That makes this 9. This then must be 3 and 6. So this is 3 and 6. We have multiple 3s. Where's 3 in box 8? It has to be here. That's the only remaining 3 possible. Therefore, where's 3 in column in box 2? It has to be one of these two. And the 3 in box 1 has to be one of these two, which eliminates 3 in the rest of rows 1 and 3 because we have a 3 here and a 3 here. Therefore, the 3 in box 3 has to be here specifically. This must add up to 49. That's the last remaining thing. And we know we have a 9 here. That's interesting. Does that tell us very much? I'm not sure. We got all the 3s sort of accounted for. 4 has to be one of these two. What about 1s? 1 is one of these two. 1 can't be here or here, so 1's one of those two, which means 1's one of those two. Okay. 2s, 2 cannot be here or here, so 2 is one of those 3. That's not very many. Okay, where's 2 in box 5? Can't be here, so it must be one of these two. 2 in box 8 cannot be here, here, or here, so this must be a 2 here. Which means 2 has to be in box 9, either here or here, but it can't be here, so because of that 2, so this is 2 here. So 2 cannot be here, or here, or here. So 2 has to be one of these two here. 2 can't be here or here. Okay, 2 in box 4 cannot be here or here, so 2 has to be one of those two, which forces 2 to be one of those two in box 1, because it can't be here because of the one of these is a 2, can't be here because of this 2, therefore that forces this to be a 2-3 pair, because those are the only digits where they can be. That means in column 2, what are the digits? We have 1, 4, 5, and 8. And this can't be 1, this can't be 4 or 8. This can't be 1. In box 8, what are the remaining digits? We have 1. Okay, 4 has to be one of these two digits because this is a 4. So that means this can never be 4 here. 4 has to be one of these two here. Okay, so we have all the 3s kind of accounted for. We do have kind of the 2s accounted for. The 4s... 4 has to be one of these two. That's not saying very much. 4 is one of these 3. 4 could be any of these 4. 4 is one of these 2. It's pretty broad. 5 cannot be here or here, so 5 has to be here. Nothing there. 6s. 6 cannot be here, so 6 has to be here in box 7. That makes one of these 6 here. This is a 1, 5, 7 triplet in row 8. This is 5 or 7. This is 1, 5 or 7, but it can't be 5. Okay. 6 can't be here, so 6 has to be in box 5, one of these two, which means 6 is one of these two in box 6. In box 2, 6 can't be here or here, so 6 has to be one of these two, which forces 6 to be one of these two. This then has to be a 1, 6 pair, because those are the only places where 1 and 6 can appear. Remaining digits in row 2 then are 4, 8, and 9. Okay. 4, 8, and 9, 4, 8, and 9. This is also 4, 8, and 9. 7 cannot be here or here, so 7 has to be one of these two. That doesn't tell us very much. 7 can't be here or here. It's one of those 3, but it's still a lot. 8 has to be one of these two. 9 also has to be one of these two. Therefore, this is an 8, 9 pair. Well, 4 can't be here. 4 can't be here, and it can't be here anymore, so this must be where the 4 is. So 4 can't be here. 4 has to be one of these two. This is 8 and 9 pair. That leaves 3, 6, and 7 remaining. This can't be 4 anymore because of the 4 in the column. That leaves this as a 4. In box 2, we have 3, 6, and 7 remaining. So this is 3, 6, 7. This is 6 or 7, and this is 3 or 7 here. In column 6, we have 1, 6, 7 remaining. This could be 1, 6, 7. This is 1, 6, or 7. Pretty broad. Remaining digits here, we have what? 2, 7, 8, 9. But this can't be 7. 2, 8, 9. This is 2, 7, 8, and 9. And it can't be 2 here. One of these two is a 6, so this can't be 6 here. We have one in box 8. We have 1, 5, 7 remaining. This can't be 1. This is 1, 5, 7. This is 1 or 7. So 5 has to be one of these two digits here. So 5 has to be one of these 3. Okay. This is at least 4. So it's 4, 5, 7, 8, and 9. These are 5, 7, 8, 9. Because it can't be 4. This can't be 7, though, because of that 7. This is 5, 6, 7, 8, 9, but this can't be 7. This can't be 5. Okay, this is... cannot be 2 or 3, so it's at least 4. And it cannot be 6. It can't be 1. Because one of these two is a 1 here. This digit cannot be 2 or 3 or 1. So no 1, no 2, no 3 or 4. This is at least 5. 5, 6, 7, or 9. It can't be 6. This can't be 9. So this is 5 or 7 here. This is actually a 2, 5, 7 triplet because of what's in the column. So that eliminates 2, 5, and 7 in the rest of the box. This can't be 7. This has to be 1 or 6. This can't be 6. So this is 1 or 6 here. That 1, 6, 1, 6 pair eliminates 1 and 6 in the rest of the row. So this cannot be 1. Therefore, where is the 1 in column 2? It could only be here. So this is 1. This is 7, which eliminates 7 in the rest of the box and the row and the column. So this must be a 5 here. 5 cannot be here or here. This is a 1. Okay. This can't be 4 because 4 is here. This can't be 5 because of the 5 in the column. So 1 has to be one of these two digits, and therefore this must be a 1-2 pair. Because of the 1-6 pair here, 1 can't be here, 2 can't be here, therefore this must be 1 or 2. This must be 4, 8, or 9, but it can't be 9 because of that 9 in the box, so this is 4 and 8. Are we guaranteed 4s here? No. 7 has to be one of these digits in box in column 3, but it can't be here, so this must be a 7 here. This must be 4, 5, or 8, but it can't be 4, so 4 has to be one of these two digits. That does eliminate the 4 there then, so this must be a 4 here. This 1-2 pair, this can't be 7 anymore. This has to be 1, 2, or 5 in row 6, but this can't be 5 or 2, so this must be 1, which makes this 2, which makes that 1. This 2 eliminates 2 here, so it's 5. This is 7. This is 2. Okay, this 1 eliminates 1 here. This is 6. This is 1. That's interesting. This can't be 6 anymore. Where is the 6 in row 4? It must be here. This has to be 5 or 8, but can't be 5 because of the 5 in the column. So this is 8. This is 5. That means this can't be 5. This is a 4, 8 pair. This 5 eliminates 5 here. This 8 eliminates 8 in the column. This 6 eliminates 6 here. So where's the 6 in box 9? It has to be here. So this is 6. This leaves a 5, 9 pair here. This can't be 5 because of the 5 in the column. So this is 9. This is 5. That eliminates 9 here and here. Okay. Okay, so we have the diagonal adding up to 49. We have 3, 7, and 9 here already with 1 and 1. 3, 7, and 9 is 19 plus 1, and 1 is 21. That leaves the other 4 digits must add up to 49 minus 21. That's 28. So what's the minimum right now? We have 7 and 8, 15, and 4 and 8. We have 1 degree of freedom, I think. Is that right? We know we know 9 is one of these. So 3, 7 adds up to 10. 9, 1 adds up to 10 plus 1. That's 21. 49 minus 21 is 28. This has to be 9. If this were 8 and 9, that would be 17. So this would be add up to 11 then. But it's not possible in that scenario. So this cannot be it cannot be 8 and 9. Therefore, this must be 4, which is 9. Because 9 cannot be here again and can't be here. So this is 4 and 9. That's 13. 28 minus 13 is 15. So this must be 15. So this is 7 and 8. This is 7 and 8, which forces this to be 7, which makes this 9, which makes that 8. This can't be 4 or 8, so this is 5, which makes this 8. 5 eliminates 5 here, so that's 7, which makes this 1, which makes that 5. The 7 eliminates 7 here, so that's 3. This is 2, this is 3. This 3 eliminates 3 here. The 2 eliminates 2 here, and this can't be 8, so this is not both of them. This is 9, this is 2. This 8 eliminates 8 here, it's 9 and 8. This 1 eliminates 1 here, it's 6 and 1. This 8 eliminates 8 here, it's 4. This is 8, which eliminates 8 and 9 here, so that's 4. This 9 eliminates 9 here, this is 8, which forces this to be 9. 7 eliminates 7 here, and this can't be 3, so it's 6, which forces this to be a 7. And that's how you solve it. Yeah, that was pretty interesting, actually. These kind of reverse arrows were very interesting along with the little killer clues, right? Because it restricted things a lot on where things could be, where digits could be placed, right? So it was interesting, particularly this one, right? Where if we tried to have a 1 here, that just wouldn't work. And then we tried to have this 4, 5 with this being 2, since this had to be 2 because the 1 didn't work here either way. And therefore, this 4 and 5 didn't work either because of contradictions that we ran into. Very cool, actually. Very nice setting. Everything just sort of, yeah, it kind of made sense, you know. Even though it, you know, looking from the outside in, it didn't look like at the start it was necessarily going to flow very well. But it seemed to flow actually very well for me. I don't know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.